Assalamualaikum and hi everyone, welcome back to my channel. So, macam mana persediaan final exam? Okay, sudah bersedia ke belum? Jadi hari ini kita nak discuss satu lagi set soalan, iaitu set soalan yang ketiga. Okay, so apa tunggu lagi? Jom kita mula. Alright, so let's start question number 1. So here we have two cables, which cable 1 and cable 2, where the tension in cable 1 is 60 Newton and cable 2 also 60 Newton. So now we want to calculate what is the resultant force exerted by these two cables, okay, to support the traffic light. Okay, so let's draw the free body diagram first. Okay, so we have y-axis and this is x-axis. Alright, so next I'm going to use different color. Okay, so from the center we have, I put it as T1, alright, where T1 is 60 Newton. Okay, so as we know from the figure 1, we have 45 degree. Okay, so if you look at here, here is 45 degree, so means that here also 45 degree. Okay, and for T2, we also have T2 here, which is 60 Newton, and here also 45 degree. Alright, so now what I'm going to do is, okay, I want to resolve T1 and T2 into X and Y components. Okay, so here we have T1, so T1X, and this is T1Y. Okay, so where this is T2X, and this is T2Y. Okay, so we can write here, okay, where T1X, okay, so awak boleh tengok sini T1X, okay, dekat dengan angle, so it's cos. Okay, so T1X is T1 cos 45, while T1Y is T1 sin 45. Okay, semua mesti tahu macam mana nak resolve. Alright, okay, macam mana nak resolve vector. So this is very important before you sit for your final exam. Okay, so now T2, how about T2? We have T2X, which is T2 cos 45, and T2Y also T2 sin 45. Okay, so we want to find the resultant force exerted by these two cables. Okay, so means that we want to calculate the total tension in X component. Okay, so you can see here we have two T1X and T2X. So we take T1X is to the right as positive sign and this is negative sign. Alright, so we're gonna have T1X plus negative T2X. Okay, so it's equal to T1 cos 45, okay, minus T2 cos 45, and T1 is 60 cos 45 minus T2 cos 45. So this T2 is 60, alright, and you will get 0 Newton. So the total tension in X component is 0. Okay, so let's move to second part is total Ty. So we're gonna have T1Y, both T1Y and T2Y, okay, both direction are upward direction. Okay, so T1Y plus T2Y. Therefore, we have 60 sin 45 plus 60 sin 45. Okay, press your calculator. So the answer is 84.9 Newton. Okay, so this is the total tension in Y component. So now we want to find the resultant force or the resultant tension, okay, by these two cables. So we're gonna have resultant T is equal to square root total Tx squared plus total Ty squared. Okay, so we substitute all the values, okay, plus 84.9 squared. Okay, and then the answer should be 84.9 Newton. Okay, remember when we have squared here, this is actually plus minus. Okay, but we consider this as positive sign because both T1y and T2y are upward direction. Alright, so 84.9 Newton is the magnitude and the direction should be upward direction. So the value is positive value. Okay, alright. Okay, so the positive value is accepted because there is an upward force that support the traffic light. Okay, so kalau kita tanya what is the weight of this traffic light, okay, you can see here. So we have T1 and T2. Okay, and here we have weight of the traffic light, which is downward direction. Okay, so since we have the total Ty is upward, you can see here. Okay, we have total Ty is equal to 84.9 Newton. So means that the weight of the traffic light also equal to 84.9 Newton. Kenapa saya kata macam tu? Because you can see here, this system, okay, is in a stationary condition. Keadaan ini adalah stationary. This is equilibrium condition. Tidak bergerak. That's mean total Fy is equal to 0. So when we write, okay, the total Fy, apa total force Fy yang kita ada tadi? Iaitu tension in Y component, okay, Ty plus negative W is equal to 0. Therefore, you can get here, the weight of the traffic light is equal to Ty, where it's equal to 84.9 Newton. Okay? Tapi soalan tak tanyalah apa weight traffic light tu. Ini saya bagi explanation tambahan. Okay? This is about chapter 4. Alright? So now the answer is, tadilah, yang mana jawapannya? This one. Okay? So the answer is positive answer, 84.9. So positive value, we accept positive value because there is an upward force that support the traffic light, that support the weight of the traffic light. Okay? So let's proceed to question number 2. Okay, question 2a, we have VT graph here, and the question asks us to calculate the average acceleration of the object during the time interval 5 seconds to 15 seconds. Okay, so means that we want to calculate what is the average acceleration, okay, from 5 seconds to 15 seconds. Alright, so now as we know that when we have a graph of V against T graph, then when we calculate the gradient of the graph, so we will get the value of the acceleration. Alright, so now let's proceed to question A1, where we want to find the average acceleration. Okay, so average acceleration is equal to V2 minus V1 over T2 minus T1, where V2 is the final velocity, V1 is the initial velocity. So here, okay, so here we have, this is the final, and here is the initial, start from 5 seconds to 15 seconds. Okay, so here is initial. Okay, when we substitute in this equation, so V final, V2 is 8 minus negative 8, alright, over T2, here is T2 and this is T1, 15 minus 5, and it's equal to 1.6 meter per second squared. Okay, so this is the answer. Alright, so number 2, okay, so we want to calculate the displacement and total distance traveled during the time interval 5 seconds to 15 seconds. Alright, so we want to determine the distance. What is the difference between distance and displacement? Okay, what is the difference? Okay, so when we have a graph of V against T graph like this, okay, so we want to calculate what is the distance and displacement. We can get the value of distance and displacement by calculating the area under the graph. So from 5 to 15 seconds, we need to calculate this area and also this area. Okay, now I will highlight the area. Okay, so here is from 5 to 10 seconds, the green color. Okay, and second one is sorry, this is the yellow color. Okay, now this is the turquoise color. Okay, so we have yellow and green. Okay, so what is the difference between distance and displacement? Okay, how to calculate distance and displacement? So when you calculate distance, okay, you need to calculate the area under the graph of VT graph, and you need to ignore the negative value from the graph. Okay, apa maksud saya ignore? Alright, let's try. So I want to find the distance first. Okay, so we need to calculate area A plus B. Okay, so it's a triangle. Alright, so the area under the graph of distance. So look at here, for A, the area under the graph A, it's half. Okay, half times 5, the base, and the height is, okay, remember, in order to calculate distance, ignore the negative sign. Alright, so here you can see here, the height of the triangle is negative 8. Tapi sebab kita nak kira distance, because distance is the scalar quantity, no direction, so ignore the negative sign. Alright, so take it as 8. Okay, so times 8. Plus, another one, another triangle, which is triangle B, we have 5. Half times 5 times 8. Okay? Alright, so the answer is equal to, okay, second we want to calculate the displacement. Okay, so when you calculate the area under the graph of VT graph, so when you want to calculate the displacement, it's a vector quantity, you need to consider the negative value from the graph. Okay, so from A, you have half times 5 times negative 8 plus half times 5 times 8. Okay, so you can see here, these two values are the same value but opposite direction. Okay, but opposite sign, positive and negative. So here is positive 20 and here is negative 20. Alright, so the answer is equal to 0 meter. Okay, so finish question 2A. Alright, question 2B. Okay, question 2B, we have a ball is thrown horizontally from the roof of a building which 45 meter tall and length 24 meter from the base. Okay, so let's say we have, okay, so 2B, so let's say we have, this is the ground, okay, and I have a building here. Okay, so we have a ball, okay, a ball is thrown horizontally, so means that in this direction, so we do have UX, tapi kita tak tahu berapa, and UY automatically is equal to 0. Alright, and it's given that the height of the building is 45 meter. Okay, and what happened to the ball? So when the ball thrown horizontally, and it will land 24 meter from the base. Alright, so this is the base, and the ball will hit the ground at 24 meter from the base. Okay, so let's draw. Okay, so this is under projectile motion, okay, and projected horizontally. So this is the final point, and the distance from the base to the final point or the landing point is 24 meter. Okay, so it's 24 meter. Alright, so from this diagram, I can take out all the values, all the information from the question. So I have Uy is equal to 0 meter per second, and since the object is moving downward, therefore Sy is negative 45 meter. Okay, so the direction is downward, so Sy is equal to negative 45 meter. And now we have the value of Sx here, where Sx is equal to 24 meter. Okay, alright, so the questions asks us to find the ball's initial speed. So the ball initial speed is referred to the value of Ux. Alright, so it's x component. Alright, so I'm going to write x component here, and in x component, xx is equal to uxt. So I'm going to use this equation. Sx equal to Ux sebab saya nak cari Ux. But the problem now, I don't have the value of t. Okay, so okay, here we do have Sx. We want to find Ux, but we don't have t. Okay, so now, okay, dari mana kita nak cari t? So it's from y component. Okay, kenapa? Okay, since we have the value of uy here, okay, equal to 0, and sy is negative 45. So I'm going to use equation sy equal to uyt minus half gt squared because I want to find t. Okay, so now we can cancel here, it's 0, and sy is negative 45 is equal to negative half 9.81 t squared. Therefore, okay, when you press your calculator, your t is equal to 3.03 seconds. Okay, that's mean the time taken for the ball, okay, to moving from its initial point to the ground is 3.03 seconds. Alright, so now you can substitute the value here. Therefore, you can get ux is equal to xx over t. Okay, so substitute the value 24 over 3.03, and finally ux, which is the initial speed of the ball that projected horizontally, ux is equal to 7.92 meter per second. Okay, alright, so finish question number 2b. Okay, question number 3, we have an eagle. Oh, saya kena lukis eagle. Okay, so sorry kalau saya tak lukis eagle. Okay, so we have an eagle with a mass of 4.3 kg moving with a speed of 7.8 meter per second. Okay, is on collision with a second eagle which has a mass of 5.6 kg with a velocity of 10.2 meter per second in a direction perpendicular to the first eagle. Okay, itu yang penting. Okay, means that, so let's say we have the first eagle. This is the first eagle. Okay, where the mass of the first eagle is given as 4.3 kg, and then it's moving in this direction with a speed of 7.8 meter per second. Okay, so please highlight for the second part where the second eagle is moving in a direction perpendicular to the first eagle. To the first two means that in this direction. So let's say I have the second eagle and the direction of the second eagle is perpendicular to the first one. So means that when u1 is moving in x component or x direction, so u2 is moving in y direction. Okay, so I will write u2, okay, here, sorry, so u2 is equal to 10.2 meter per second, where the mass of the second is 5.6 kg. Okay, so this is before collision. Okay, what happened? Okay, after they collide, they hold on to one another. That's mean they stick together. Okay, so let's say this is the condition. Okay, so I have M1 and this is M2, and they are stick together. Alright, so in what speed and direction are they moving after the collision? So I don't know what is the final speed, but they are moving together means that final speed ada satu sahaja, and the mass will be combined M1 plus M2 V. Alright, so now I don't know what is V. Okay, saya bulatkan saja. And in what direction? Kiri ke atas? Saya tak tahu. Okay, what direction? Okay, direction tak tahu. To the right or upward. Okay, sama ada dia to the right or upward. Okay, ataupun angle. Ada angle. Okay, so obviously when we have two objects that moving in x and y component and then they collide to each other, what happen? They will move in a direction. Okay, kita tak tahu in what direction, at angle of what. So kita kena kira. Okay, so now we have before and after collision. Okay, so this is after. Alright, so now I'm going to write, okay, so total momentum by using conservation of momentum. So total momentum initial is equal to total momentum final. Okay, so total momentum initial is equal to total momentum final. Okay, so here saya akan separatekan, this is in X component and this is in Y component. Kenapa saya asingkan? Kenapa mesti asingkan? Because this is 2-dimension collision. Okay, 2D collision. Okay, so this is 2D collision. How do we know this is 2D collision? Okay, how do we know? So from here you can see here, okay, initially U1 is moving in X component, but U2 is moving in Y component. Alright, so obviously we have two direction, okay, two different direction of U1 and U2. Okay, so for this case we need to divide, okay, the calculation into X component and Y component. Alright, so you can see here in X component, so we can write M1 U1x plus M2 U2x equal to, so after collision you can see here, okay, M1 and M2 stick together. Alright, we have M1 and M2, so we do have one value of V. Okay, so we're gonna have Vx. So kita combinekan mass dia, M1 plus M2, and since this is X component, so put as Vx. And how about this one? I will use another color. So M1 U1y plus M2 U2y equal to M1 plus M2. This time we write Vy. Okay, so now let's substitute all the values. So M1 U1x, tengok pada soalan, betul tak U1 bergerak in X component? Yes, kita lukis tadi betul. So we just substitute. M1 is 4.3, okay, U1x is 7.8, but U2x is 0. Okay, kenapa U2x is 0? Because, okay, U2 is not moving in X component. Initially, pada awalnya, U2 is moving in Y component. Okay, so it's equal to 0, and this one is 4.3 plus 5.6 Vx. Therefore, Vx is equal to 33.54 over 9.9 is equal to 3.39 meter per second. So this is the final velocity in X component. How about Y component? Okay, so M1 U1y, so look at here. Okay, the first eagle yang pertama tidak bergerak in Y component. Okay, pada awalnya U1x sahaja dia ada, U1y tiada. Alright, so we write 0 plus 5.6 times, so U2 is moving in Y direction, so 10.2, okay, is equal to, alamak tak muat 4.3 plus 5.6, okay, Vy. Okay, so rearrange the equation. Vy is equal to 57.12 over 9.9, so it's equal to 5.77 meter per second. Okay, so now we calculate V. So we want to calculate what is the final speed, alright, after the collision. So it's equal to the square root of Vx squared plus Vy squared. Alright, so substitute. So we're going to have 3.39 squared plus 5.77 squared. So the answer is 6.69 meter per second. Okay, and what is the direction? Okay, remember we need to calculate the direction. Therefore, the direction is theta is equal to inverse tangent Vy over Vx. So it's equal to, so make sure you substitute the correct value. Vy jangan tersilap, 5.77, and Vx is 3.39. Therefore, theta is equal to 59.56 degree. Okay, so in what direction? Okay, you can see here. Macam mana kita nak tahu after pelanggaran dia bergerak ke mana. Okay, so look at here, Vy is positive value and Vx also positive value. So when we try to sketch the direction of motion for these both eagles, okay, so Vy is positive value, so upward, so this is Vy, and Vx is positive, so to the right, so means that the final velocity is in this direction of V, where it's equal to 6.69 meter per second, and the direction, the angle is 59.56 degree. Okay, so kita dapat tahulah dia bergerak ke sini. Okay, so means that kita boleh cakap the direction, okay, the direction of motion is above the original path of the first eagle. Okay, initially the first eagle is moving in this direction to the right, bergerak and collides with the second eagle, and what happened after the collision? Okay, both moving in this direction. Okay, V 59.56. Okay, we can write as, okay, the direction is above the original path of 4.3 kg eagle. Okay, 4.3 kg eagle tu refer kepada eagle yang pertama tadilah. Okay, so the first eagle is moving in this direction, then after the collision, the direction of the motion is in this direction, which is above the original path of 4.3 kg eagle. Okay, kalau tak dia bergerak ke sini kan, tapi disebabkan pelanggaran dia pun bergerak ke atas. Okay, macam mana saya tahu dia bergerak ke atas? Saya ulang lagi sekali, because Vy is positive, so we draw Vy is upward, and Vx also positive value, and positive value is to the right. Okay, Vy is positive, so upward, Vx is positive to the right, so V must be between them. Alright, so the angle is 59.56. So finish question number 3. Okay, question 4. We have a woman at an airport is towing her 20 kg suitcase at constant speed. Alright, so let's draw. Okay, so this is the floor and this is the back. Okay, and this is the arrow. Okay, alright, so the woman pulling the bag, okay, at angle of, no, we don't know, so this is the angle. Okay, so theta and F1, so the force from the woman is given as 35 Newton. Okay, okay, and given that the frictional force on the suitcase is 20 Newton, means that we have the frictional force opposite direction and it's 20 Newton. Okay, so secara logiknya, when we try to pull the bag to the right, okay, in this direction, so the bag will move to the right, so in this direction. So this is direction of A, so A is equal to 0 meter per second squared, since the question state that case is moving at constant speed. Okay, and here we have a normal force as usual, because we have a contact between the object and the surface, and also the weight is downward. Alright, so question A, draw a free body diagram of the suitcase. Okay, okay, so we're gonna have y-axis and x-axis. Okay, alright, so this is the dot to represent the object. Alright, so normal is upward, and F1 is in this direction at angle of theta, and the weight is downward, and the frictional force in this direction, and it's 20 Newton. Okay, so semua ada, direction mesti betul, okay, mesti label arrow, and arrow mesti betul. Okay, so tail of the arrow must start from the dot. Okay, so full mark. So B, we want to start the calculation, because the question state that calculate the angle. Okay, what angle does the strap make with the horizontal. So you want to find angle theta. So before you start your calculation, make sure you resolve any force, okay, that the position of the force at some angle of theta. Alright, so we're going to have F1x is equal to F1 cos theta, cos sebab sebelah dengan angle, and then this is F1y, where F1y is equal to F1 sin theta. Okay, so let's start our calculation. So we want to find what is the angle of theta. So what if we write total Fx is equal to ma? Okay, so the object is moving with constant speed and acceleration is equal to 0. So total Fx is equal to 0. So now look at to the free body diagram. So here we have two forces, which are F1x and frictional force. Alright, so now let's write F1x plus negative friction is equal to 0, and F1x is F1 cos theta and it's equal to the friction. Therefore, we can find, okay, cos theta is equal to F over F1 and theta is equal to, and the angle is equal to, okay, 55.15 degree. Okay, so this is my answer. And C, okay, so I will write C here. I'm going to use black color. Okay, C, we want to find what is the magnitude of the normal force that the ground exerts on the suitcase. Okay, so look at here. Okay, on y-axis we have three forces: normal, F1y, and W. Okay, so first please write total Fy is equal to 0. Sebab normal force dekat y component, so tulis total Fy is equal to 0, and N plus F1y because the direction is upward plus negative W downward equal to 0. Okay, jangan lupa ni negatif. Okay, kalau you salah tulis you punya equation, the whole calculation pun akan salah. Okay, so N is equal to W minus F1y, and W is equal to mg minus F1y is F1 sin theta. So we can use theta from the previous part. Alright, therefore N is equal to mg is 20 times 9.81 minus, alamak tak muat, saya letak bawah, F1 is 35 sin 55.15 degree. Okay, therefore N is equal to 196.2 minus 28.72. Okay, and finally the normal force is equal to 167.48 Newton. Okay, so this is the answer. Alright, so finish question number 4. Let's proceed to question number 5. Okay, we start question number 5 with 5A first. Okay, so 5A, we have a horizontal force of 150 Newton is used to push a 40 kg packing crate at a distance of 6 meters on a rough horizontal surface. Okay, so means that we have the surface. Okay, we have a surface and this is the crate. Okay, and now we want to draw the horizontal force. Okay, we try to push. Okay, so means that the force in this direction. F is equal to 150 Newton and the mass of the object is 40 kg. Okay, and it's moving with a distance of 6 meters. Okay, so let's say the object is moving. Okay, so S is equal to 6 meters. Okay, alright, so it's moving with a constant speed. So another information, we know that V is constant. Alright, find the work done by the frictional force. So we want to calculate what is the work done by the frictional force, and this is the frictional force, opposite direction with the motion. Okay, so motion dia ke mana? Okay, motion dia ke sini lah, V dia. Okay, so now let's calculate what is the work done by the frictional force. Okay, so W is equal to, okay, tengok sini so we want to find the work done by the frictional force, and it's equal to Fs cos theta, where F, the type of the force now is friction, because we want to find the work done by the frictional force. So Fs cos theta. Okay, so the angle theta here is the angle between, this is the angle between, okay, between friction and S. So now you can look at here. Okay, so S, the direction of S is to the right. Okay, and frictional force is opposite direction. You can see here the angle between them is 180 degree. Okay, so we can substitute Fs cos 180 degree. But now we want to solve this problem, but we don't have the value of, kita ada S, but we don't have the value of friction. Okay, so how to find friction? Okay, we need another calculation. Okay, kita kena cari dulu friction, where the friction, you can write the total Fx is equal to ma. So this is from chapter 4. So since we know that the object is moving to the right, and there is an external force which is 150 Newton minus friction, and it's equal to ma. Okay, so it's F minus friction is equal to ma, but it's constant speed, and a is equal to 0, and a is equal to 0. Therefore, F is equal to F. So the frictional force is equal to 150 Newton. So the frictional force is equal to 150 Newton. Now we can proceed to calculate WF. The work done by the frictional force is equal to 150 Newton. S is 6 meter. Cos 180 is negative 1. Therefore, the answer is equal to negative. So negative is a must. Okay, so you must put the negative value here. Negative 900 joule. Okay, so saya highlightkan kat sini. Alright, so work done. Okay, kalau work done F, that one is the work done by the frictional force. So it's negative lah. Okay, so the work done by the crate to overcome the frictional force is equal to negative 900 joule. Okay, sebab dia melakukan kerja untuk melawan frictional force. If the work done on the crate, so positive value. When the work done by the crate, so it's negative value. So ini maklumat tambahan lah. Okay, so ini hanya maklumat tambahan. Okay, so finish question 5A. So now let's proceed to question 5B. Okay, question number 5. So now we have a spring. Okay, where okay, question number 5B. So here we have a ball of mass 1.8 kg, and we also have a spring. Okay, so where the ball is released from rest at height h equal to 65 centimeter above a light vertical spring. So you can refer to the figure 4. Okay, so here we have, you can look at here. Okay, here h is equal to 65 centimeter. Okay, so what happened to the spring when the ball strikes the top of the spring, and then the spring compress at distance of 9.00 centimeter. Okay, means that from here, Okay, so means that here is the amount of compression of the spring, which this is, I put as X, is equal to 9 centimeter. Alright, so now let's read the question first. Okay, so the first question, we need to find the speed of the ball just as it touched the spring. Okay, so let's say, okay, this is the first condition. Okay, and this is the last condition, I put as 3. Okay, the second condition where the spring, okay, so I'm going to draw the spring. Okay, so the second condition where the spring not compressed yet and the position of the ball just at the top of the spring. Okay, dia hanya touch dulu spring tersebut. Okay, you bayangkan in a slow motion. Okay, so here. Okay, so here I will put as second condition. Alright, so now in order to answer question number 1, I will consider, okay, condition number 1 and number 2. Alright, so I'm going to use conservation of energy. Okay, so by using conservation of energy, total energy 1 is equal to total energy 2. Okay, so you can see here, alright, so I'm going to use highlighter and I will put this line as my reference line. Okay, so the yellow color is my reference level. Okay, so this is my reference level. Okay, what is reference level? Why I put reference level? So when I put reference level, means that I will ignore the height of the spring. Okay, so saya hanya ambil bola itu daripada atas jatuh ke sini. Okay, so the height of the ball is just 65 centimeter, and when the ball touch the top of the spring, so no height. So saya ambil ini sebagai reference level. Alright, so now you can see here based on the condition. Okay, so now you can see here based on the first condition. Alright, the type of energy at the first picture. Okay, number 1. Okay, so the ball is at the height of 65 centimeter and it starts from rest, so 0 meter per second, U is 0. So means that at 1, the type of energy at 1 is gravitational potential energy. So kita pun letak U. Okay, and what happened to the ball at second condition? Alright, at second condition, the ball is moving downward. And here we have a speed of V. So now we have kinetic energy at second condition. Okay, so kinetic energy. So when we write our equation, the potential energy equation is equal to the kinetic energy. M is the mass of the ball, and it's given the mass of the ball is equal to 1.8 kg. Okay, so mv squared. So we can cancel M, and now I can find what is the speed of the ball just as it touched the spring. Okay, so V is equal to 2gh and then square root. Alright, and then you can substitute the value. Okay, and height here, h here is 65 centimeter. Make sure you change to meter, so it's equal to 0.65. Okay, and the final answer is equal to 3.57 meter per second. So now we can proceed to the second question. Okay, we want to find the force constant of the spring, ataupun kita panggil sebagai spring constant. Okay, so second question, we want to find what is K, the force constant of the spring ataupun spring constant. Okay, so you can see here in the third diagram, the spring is compressing. So there is an elastic potential energy in the spring. Okay, so you can calculate. Alright, so now you can consider. Okay, you nak pilih diagram number 1 as your initial diagram or second diagram as your initial diagram, and this would be your final condition. So, ini nak jadi initial ke ini? Okay, mana-mana you pilih, tak ada masalah. Jawapannya akan sama. Okay, let's say I'm going to choose this as my initial condition and this is my final condition. So, I will write by conservation of energy, okay, total energy initial. So, I'm going to use 1, total energy 1 is equal to total energy at the third stage. Alright, ataupun at the third condition. So, initially, okay, before we start, you need to set your reference level. So, kalau untuk soalan pertama tadi, saya set reference level saya yang warna kuning. So, semua yang bawah ini, saya ignore. So, now for this second question, I will set my new reference level. You can see here. Okay, ini saya padam dulu. So, I'm going to draw my reference level here. Okay. So, seolah-olah bawah ini tiada. So, ini we cancel. Okay. Alright. So, now this is my reference level. Okay. Okay, bila saya dah set reference level saya, so yang bawah tu saya akan ignore. Okay, you can see here, the height of the ball, okay, in the first stage is 65 cm plus this height, which is 9 cm. Okay, so ini saya lukis, this is 9 cm. Okay, so now for the second one, so we have a compression of 9 cm, and remember, okay, at maximum compression, okay, bayangkan bola tu jatuh and then spring tu compress sehingga ke bawah. So at maximum compression, okay, the velocity is equal to 0. Therefore, the kinetic energy equal to half mv squared. So no kinetic energy at the third stage. Okay, so what type of energy yang kita ada at third stage? Since the spring is compressing to the maximum compression, so means that there is an elastic potential energy of the spring. Okay, so we can write the equation. So on the first stage we have UG and second we have US. Okay, so now I will write the equation mgh equal to half kx squared, and we want to find k because this is our objective. Okay, so now look at the diagram. Height mgh, what is the height? Okay, height dia sekarang bukan lagi 65 cm. Okay, sebab kita dah setkan kita punya reference level from here. Okay, dari mana dia mula? Start here, and then this is the finish line. This is the reference level, the finish line. Alright, so the height of the ball would be 65 cm plus 9 cm. Okay, you can see here where the mass is 1.8 times 9.81 and the height is 0.65 plus 9 cm convert to meter is 0.09, and it's equal to half k. We want to find k, and how about x? X the amount of the compression of the spring. Okay, so this is x, 9 cm. Awalnya tinggi dia macam ini tadi, and then bila dia compress, so the amount of compression, initial length minus final length, so it's equal to 9 cm. Okay, itu telah diberi dalam soalan. Okay, so k 0.09 squared. Therefore, you can calculate your k, where k is equal to 3226.4 Newton meter. Okay, so this is the answer. Alright, okay, this is the other method, or you can use, so saya tunjukkan juga. Okay, so this is the second stage tadi. Alright, before the spring compress and at the condition where the ball touch the top of the spring, this is second condition, and this is the final condition where the spring is compressing. Okay, so you can see. Okay, so where is my reference level? So dia mula dekat sini, dia berakhir di sini. So saya akan buat line. Alright. Okay, so this is the third one. Okay, let's say you want to use the total energy at second stage equal to the total energy at the third stage. Pun boleh. But you need to know what type of energy that involved in the second stage. Alright, so here as we know, this is the amount of compression X and it's equal to 0.09 meter, and this is also the height. Okay, H is equal to 0.09 meter. Alright, so kat mana dia mula? Bola dekat sini, dan dekat mana dia akhir? So saya ambil ini sebagai our reference level. Sekejap So saya ambil ini sebagai our reference level. Okay, so yang bawah ini saya akan ignore. Alright, so I will write UG is equal to half kx squared. Okay, we have UG, and remember, at second stage, the object is moving downward with the speed of 3.571. Okay, 3.57113. Okay, kenapa saya ambil sampai 113? Sebab supaya jawapan dia kita nak dapat lebih kurang sama dengan yang ke atas. Okay, kalau you ambil 3.57, dia akan ada lari sikit. Okay, dia punya decimal places dia. Okay, macam biasa. Okay, so now kita betulkan balik. In the second stage here, we have the potential energy sebab ada height, and then the object is moving, so there is a kinetic energy. Okay, so we can erase this. Okay, so we have UG plus kinetic energy, and we write mgh plus half mv squared equal to half kx squared. Okay, saya akan sambung dekat sebelah. Alright, so m is equal to 1.8. Okay, boleh terus saja masukkan. Okay, 1.8 times 9.81 times 0.09. So the height is 0.09. Okay, plus half m is 1.8 and v is 3.57113 squared, and equal half k x is 0.09 squared. Okay, so now let's start our calculation. 1.8 times 9.81 times 0.09. So here we have 1.5892 plus half times 1.8 times 3.57113 squared, and it's equal to 11.4776 equal to, okay, 4.05 times 10 power of negative 3k. Therefore k is equal to, okay, 1.5892 plus 11.4776. Okay, divide. The one is 4.05 times 10 power of negative 3. Okay, so I got 3226.4 Newton per meter. Okay. Okay, kenapa saya ambil ini terlalu panjang dia punya decimal point? Okay, sebab saya nak dapatkan jawapan yang sama macam yang ke atas. Kalau you bundakan terlebih awal, okay, so jawapan you akan lari sikit lah. Okay, so finish question 5B. So let's proceed to question 6. Okay, question number 5C, we have the electric motor of a model train accelerates the train from rest, okay, to 0.62 meter per second in 21 milliseconds. Okay, so we have electric motor, okay, where the electric motor accelerates the train from 0 to 0.62 meter per second. Okay, so in 21 millisecond. Alright, so find the average power delivered to the train during its acceleration. So we want to find the average power. So P of the motor, okay, is equal to, as we know, the equation of power is energy over time, or P is equal to W over T. Okay, so saya highlight. Okay, so now we want to find power. So here we have time, but we need to find work. Okay, work done to move the train. Alright, therefore by using the work energy theorem, okay, so since there is a change of kinetic energy of the train, we can write as W is equal to delta K and K final minus K initial. Alright, and oops, what happened? Okay, kita tulis lagi sekali, W equal to delta K and K final minus K initial, where K final is half mv squared and minus K initial half mu squared, but initial kinetic energy is equal to 0 since U is equal to 0. Alright, and W is equal to 0.168 joule. Okay, you can substitute the value. Alright, V. Therefore, we can find P of the motor is equal to W over T, and it's equal to 0.168. Divide the time in millisecond. Make sure you change to second. 21 exponent negative 3 second, and it's equal to 8.01 watt. Okay, that's all. Okay, so now let's proceed to question number 6. Okay, now look at question number 6. We have figure 5 shows a 4 kg object is attached to a vertical rod. So now we have here the mass of the object is 4 kg. Okay, and the object rotates in a horizontal circle and the radius here. So here we have R. Okay, where R is equal to 1.3 meter. Okay, and at speed of V is 6 meter per second. Alright, calculate the tension TA in the upper string and the tension TB in the lower string. Okay, so before we start, let's sketch the all the forces that involved in this diagram. So we have weight downward, and we have TA, and here we have TB. Okay, so let's draw the free body diagram. W is downward, and we have TA here, and here is TB. Okay, so the angle here is 50 degree, and here also 50 degree. Okay, so now we need to resolve TA and TB into X and Y components. So we have TAY, and here we have TAX, and for TB we have TBY, and here is TBX. Okay, alright, so the direction of the centripetal acceleration, okay, saya buat kecil saja. Okay, AC. Alright, we know that the direction of the centripetal acceleration is AC, is towards to the center, okay, of the circle. Alright, so now let's write the equation. Okay, we have the total force X is equal to MAC, because now we want to calculate what is the tension and TA and TB. So we need to write the equation first. Alright, and look at the free body diagram. So in X component we have TAX and TBX. Okay, we have two types of forces here. Okay, so TAX plus TBX is equal to mv squared over R. Okay, so TAX, okay, so TAX is T cos 50, okay, and TBX is, so this one is TA, TB cos 50 is equal to M is 4, V is 6 squared over R is given 1.3. Okay, so now we can try to solve this one. We have TA plus TB cos 50 is equal to 110.77. Therefore, TA plus TB is equal to 110.77 over cos 50. and TA plus TB is equal to 172.33. Awak cuba tekan kalkulator. Awak mesti practice tekan kalkulator, jangan salin saja. Okay, practice tekan kalkulator, nanti dalam exam awak akan jadi kelang kabut kalau tak reti tekan kalkulator. Okay, so I let this equation as equation number 1 because we have two unknowns. Okay, I always remind you that when we have two unknowns here, means that we need another equation. We need two equations to solve the value of the unknown. Alright, so now let's proceed to the total Fy is equal to 0. Since the object is not moving in y component, so straightly write 0. Okay, so now check your free body diagram. Okay, so here in y components we have TAY plus negative TBY plus negative W. Alright, so I'm going to write TAY plus negative, because the direction is downward, TBY plus negative W is equal to 0. Therefore, okay, TAY is TA sin theta. Okay, you can see here TAY jauh daripada angle, so sin TA sin 50. Okay, so this is TA sin 50 and this is TB sin 50. Alright, so we substitute TA sin 50 minus TB sin 50 minus mg is equal to 0. Now I want to solve this equation, and I have TA minus TB. I'm going to factorize sin 50 equal to mg. Okay, therefore TA minus TB is equal to 4 times 9.81 over sin 50. Alright, so the answer should be TA is equal to 51.22 plus TB, and I let this as equation number 2. Okay, so now I will substitute TA here. Okay, so I will substitute TA here into first equation. Okay, so let's try to solve. Okay, substitute equation number 2 into equation number 1. Okay, alright, so we have TA here. Okay, so we can straightly substitute 51.22 plus TB is equal to 172.33. Therefore 2TB is equal to, okay, tolakkanlah 172.33 minus 51.22, so you will have, is it? Tolak kan? Okay, so 121.11. Therefore, TB is equal to 60.6 Newton. So this is the value of tension for the lower string, TB, and in order to find TA, therefore TA is equal to 51.22 plus TB. Therefore, 51.22 plus 60.6, and it's equal to 111.82 Newton. So this is the tension for the upper string. Okay, so we finish answer question number 6. Alright, so let's proceed to question number 7. Okay, question 7, we have the International Space Station ISS is launched from the Earth and orbiting at an altitude of 350 km. Alright, so let's say we have Earth here. Okay, and this is the ISS. Okay, where the ISS orbiting the Earth. Okay, so where ISS orbiting the Earth. Okay, at this direction. Okay, tak bulat sangat ni. Something like that. Okay, at an altitude, so given that here is H, so given the altitude is 350 kilometer. Okay, so the center of the Earth here is RE. Where RE is equal to 6.38 is given 6.38 exponent 6 meter, and the mass of the earth is given 5.98 times 10 power of 24 kg. Okay, so the mass of the ISS is not given, so we don't know what is the mass of the ISS. Okay, so let's answer the first question. Okay, so the question states that determine the velocity of the ISS in order to escape completely from the Earth gravitational pull. Okay, so we want to find the escape velocity. We can just substitute in the equation. Okay, so square root 2gm. M here is the mass of the Earth, and here is the R. Okay, so the radius of the Earth. Okay, so 2 so square root 2 times 6.67 exponent negative 11, and the mass of the earth is given as 5.98 exponent 24 divide the radius of the earth is 6.38 times 10 power of 6 meter. Okay, so the escape velocity is equal to 11.18 times 10 power of 3. Is it 11.18 times 10 power of 3 meter per second? Okay, and how about question B? Okay, so let's try to answer question B. Question B asks us to find the wake of the ISS when in its orbit. So given that, okay, the wake of the ISS is equal to 4.22 times 10 power of 6 kg. This is at the surface of the earth. Okay, alright, so we want to find what is the wake. I put as W prime of ISS at its orbit. Okay, so means that here at the position of from RE plus H, okay, at its orbit, so on this line. Okay, so it's equal to R is equal to RE plus H. Okay, so now, so let's write the equation of gravitational acceleration or gravitational field strength. G is equal to Gm over R squared. Okay, so this is the equation. Okay, I put this one is capital R, RE squared. Okay, so let's say at the surface of the earth. Okay, so G is equal to Gm over R squared. Alright, so now let's write the equation of wake. So W is equal to mg. Okay, so now let's proceed. Okay, so let's write wake at the surface. Okay, so wake at the surface, so W is equal to mg. So I'm going to write W at the surface is given as 4.22 times 10 power of 6 equal to, okay, the mass of ISS, kita tak tahu, we are not given the mass of ISS, okay, times the gravitational acceleration or gravitational field strength, Gm, the mass of the earth, over RE, okay, because on the surface of the earth, so RE squared. Okay, okay, so now for the second part, okay, maybe we can try to solve first. Okay, so we can find MISS, okay, MISS times GME is actually equal to, ataupun kita dah boleh cari mass of ISS. Okay, kalau ni saya cari dulu, saya calculate ini saja. So the radius of the earth is given as 5.38 exponent 6 squared. Okay, so kita dapat cari dulu mass of ISS times GME. Kalau you nak cari mass of ISS ni pun boleh. Okay, so divide saja dengan GME. Okay, tapi saya nak teruskan ini saja, saya nak cari ini saja. Okay, mana-mana pun sama. Okay, so the answer is 1.718 times 10 power of 20. Okay, so now, okay, let's write what is the weight at its orbit. Okay, weight at its orbit. So kita tak tahu, I just put W prime. So W prime is equal to mass of ISS times G, the mass of the earth, the point mass, over, okay, R. Okay, di mana it's RE plus H on its orbit squared. Okay, okay, I think you can calculate first what is RE plus H. So after the calculation, you will get RE plus H is equal to, okay, this one should be equal to 6.7 exponent 10 power of 6 meter. Okay, awak cuba kira Alright, so now the weight of the ISS at its orbit is equal to, so let's start. So W prime is equal to, alright, look at here, we have, okay, the mass of ISS times GME. Okay, tengok sini, kita dah ada, kita dah kira tadi ke atas ni. Okay, so we can straightly substitute 1.718 exponent 20, okay, over RE plus H is 6.7 times 10 power of 6 squared. Okay, press your calculator, and then the final answer, weight at its orbit, is equal to 3.8 times 10 power of 6 Newton. Okay, so this is the answer. Okay, so saya ulang lagi sekali. So at this point, okay, if you want to find what is the weight of the, if you want to find what is the mass of ISS, kat sini dah boleh kira. So 1.718 times 10 power of 20 here, divide gravitational universal constant and the mass of the earth. So you dah tahu nilai dua unknown ini. Okay, so you divide saja dengan 1.718 times exponent 20, then you akan dapat mass of the ISS. Okay, so you boleh substitute lah. Okay, tapi saya tak nak masuk 2-3 kali nak masukkan dia punya nilai. Saya kira ini saja, where MISS times GM is equal to 1.718 exponent 20. Then here, yang saya bulatkan warna hijau ini, saya masukkan di sini. Okay, 1718 exponent 20 and divide R. Okay, where as you know that R, okay, this is actually the small r. Okay, R is equal to RE plus H. So kira lah, RE you dah tahu. Okay, the altitude, the H you ada nilai, then you akan dapat lah R is equal to, okay, 6.7 exponent 6. Then you can substitute here. Okay, okay, so let's try to answer question C. Okay, so 7C. So determine the velocity and the period revolution of the ISS in its orbit. So in its orbit, okay, R is equal to, yang kita dah kira tadi, RE plus H is equal to 6.7 exponent 6 meter. Alright, so now we want to find what is the velocity of the ISS when moving in its orbit. Okay, so V is equal to square root GM over R. We can straightly use the equation. Okay, so G 6.67 times 10 power of negative 11. Alright, and the mass is 598. Tadi dah ada 598 exponent 24 divide 6.7 times 10 power of 6. Okay, and the answer is equal to 7.7 exponent 3 meter per second. Okay, so make sure you cari ini dulu. Okay, ini tadi kita dah kira sebenarnya. Okay, next. So the period, you can calculate the period by using this equation. Okay, the first method. Okay, you can use this equation. T is equal to 2 pi square root r cube over gm. Okay, this one. Or method 2. Okay, you can find T because we know that V is equal to D over T. So for one complete circle, 2 pi r over T. Okay, therefore T is equal to 2 pi r over V. V tadi kita dah dapat kat atas kan, you boleh kira jugalah. So kalau saya substitute 2 pi and r is 6.7, kita dah kira tadi, times 10 power of 6. V kita adalah 7.7 times 10 power of 3. Therefore, T is equal to, okay, cuba tekan calculator and then calculate. So, the answer is 5467. Okay, 5467.2. Okay, 0.2 second. Okay, so if you use second method, so your answer is 5467. Okay, sebenarnya mungkin lari sikit. Okay, sebab you punya V here, okay, you boleh tengok you punya V here, ini you dah bundakan 7.7 because it's actually 7.698 exponent 3. So dia akan beza sikit lah dengan jawapan yang kat sini. Sini pun you boleh terus substitute 2 pi, okay, where r is equal to 6.7 exponent 6 cube over 6.67 exponent 11 times the mass of the earth is equal to 5.98 exponent 24. Okay, cuba tengok berapa you dapat yang ni. So sini you akan dapat 5456. Ikut cara kita tekan kalkulator lah, tapi ini yang kita dapat 5456.05 second. Okay, kenapa ada ralat macam ni? Okay, sebab mungkin kita guna this one is 6.7. Okay, R here is actually 5 point, let's say we have 350 km plus 6.38 is the radius of the earth, exponent 6. Okay, so sini saja sebenarnya bukan 6.7. Okay, sudah ada lalat lah. So here is 6.73 exponent 6 meter. Okay, so kalau kita pakai dekat sini, so kita masukkan 6.73, so cube kan. Okay, and divide 6.67 exponent 11 times 5.98 exponent 24, and then take the square root and then times 2 pi. Okay, kita dapat 5492.74 second. Okay, cuba kita check balik. So ini kalau kita buat 6, so let's say kita tengok yang kat sini 6.7 ni, kalau kita tukar 6.73, okay, kita tambah 6.73, so 6.73 exponent 6 times 2 pi and divide. So 7.7 ni saya nak letak 7.698 exponent 3. So saya tak bundakan awal-awal, 7.968 exponent 3. Awak cuba kira sama-sama. So kita akan dapat 54. Lari jauh Okay, kalau kita bundakan daripada awal, kalau awak punya R ini kita bundakan 6.73, okay, kita bundakan kepada 6.7, dia akan lari So jawapan yang bawah ni saya dapat, okay, so jawapan saya dapat 5493.1 second. Okay, so 5493.1 second close to this one 5492.74. Okay, so ada beza kalau kita gunakan awal. Okay, tapi jalan kira dia betul, tak ada masalah. Awak tengok awak bezakan. So ini method 2 and then this is method 1. Okay, alright, so finish question number 7. So let's move to question number 8.